Hi everyone, if you're looking to get a little more assistance on understanding distance, rate, and time problems, you're in the right place. I'm giving you a sample problem here that I made up, and I'm going to model this problem with the DRT diagram. And remember, the DRT diagram is just something that I came up with because I just simply can't come up with a better term than dirt. And the reason why we call it dirt is because we're using the original equation of distance equals rate times time, remember? So if we wanted to write that down as an actual equation, it would be rate times time. So you can actually use either one, but it seems like most of you like the little dirt triangle that we use because it just kind of sets it up easily and it shows the relationships between the numbers very well. Okay, remember, when you look at this triangle, when you see these values next to each other, that means multiplication, just like in an actual equation, when two values are next to each other, it indicates multiplication. And when you see numbers that are on top and below each other, it looks like a division. And you remember that I always say that division problems, fractions are division problems waiting to happen. So this is distance divided by rate. That'll get you the time. This is rate times time, which will give you the distance. And this is distance divided by time, and that'll get you the rate. So you can plug in your values wherever you want. And as long as you use the values and plug them in correctly in the actual triangle, then the relationships are easy to see, and it's as simple as calculating the answer and moving on. So let's try this one. Mr. Marzillier's parade float, you knew I was going to give you this one, travels a distance of 24 miles in New York City. If it travels for 3 hours, how fast did it move? So a couple of things to consider here. When we look at the problem, we have some data that we have to pull out. 24 miles in New York City, that's its distance. So we're going to put 24 in the place where distance should go. Right? If it travels for 3 hours, when we talk about hours, hours are a measure of time. So we're going to substitute in our triangle for time. We'll put in 3 hours here, and that goes right there. How fast did it move? The question is asking you how fast it actually moved. So when we try to calculate how fast something goes, that's its rate of speed. And so the rate is the unknown piece here. That's the part we don't know. Now we can figure this out pretty simply. Just cover up with your finger the part that you don't know. And so for us, the part that we don't know is the rate, so we'll ignore that. And we're just going to focus on the relationship of the 24 and the 3. Look at how they're written. It looks a little bit like 24 over 3, which is 24 divided by 3. And that, 24 divided by 3, gives you 8. Therefore, your rate is the factor that we're missing here. So the rate of speed is 8. Now the only other thing that you have to remember is that when we talk about these answers, and we talked about this in class today, you have to be very careful because they need labels, right? So speed is always really measured in two things. It's distance and it's time. And that's going to come from the problem. So the distance here was miles. So it travels 8 miles, which I'll abbreviate with MI, per time. And time was measured in hours. So the other value that we're going to compare it to is hours. So the parade float travels 8 miles per hour. Remember to do that on your homework. You have to give it a label. And with speed, it's always a measure of distance against time. All right, so good luck with the rest of the work. If you ever need this again, you can come back here and check in whenever you want. Remember, wash your hands because you used Marzillier Math Dirt. It's a little joke. Get it? Dirt. You have to wash your hands. Never mind. Bye.